Alright, welcome back to part 3 of this RTS Unity Units tutorial series. Today we're going to be talking about Boids. So I don't know how common it is to use Boids in regular games, but I ended up using it for mine because it was kind of a neat, easy little solution that looks neat, I thought, and it scaled pretty well. So that's what I'm going to be showing you guys how to do today. So if you haven't watched that steering behaviors video, go watch that now. So first we're going to create an object. You can make it whatever you want, just some sort of 3D object that you can see. We're going to call it squad parent, and this is going to be what instantiates all of our squad members and what they follow and what's giving them all the commands and stuff, right? So now we're going to attach a script to that, call it squad parent script or something similar. And go ahead and open that up in whatever your code editor is. Okay, so just like in the last video, this is going to have a target, so we want a public game object target for this thing to follow. We're also going to have the child prefab. Now this is going to be what the members of the squad are. On start, it's going to instantiate all these squad members, so that's how you're going to assign it. Then we're going to want a list of all of our children, so once we instantiate all of those prefabs, we're going to want to keep them in a list to keep track of them as the game goes on. So in start, we want to initialize that list. So we're going to make a for loop, and that middle number, I'm going to pick 12, that's going to be how many units we're going to instantiate. So I'm going to create a vector 3 that's called like relative spawn point or something like that. And we're going to adjust the x direction by the modulus of the index, or we're going to adjust the y direction by the division of the index. And this is just going to make our guys like spawn in columns, basically. All right, so now we're going to instantiate those prefabs as temporary game objects and make sure that they spawn at the relative transform of the parent object plus that offset that we just created. Now for each of those children, we're going to set the target to the parent object, so that way all of the little units are always going to follow the parent. Then we're going to add that temporary game object to the list, and we're done instantiating all of our dudes. Nice. And an update, we're going to do a really simple behavior. We're just going to make sure that the parent object is always moving towards some sort of target every single frame. And now we save and go into the Unity game editor software thing. And we're going to assign those children. And when we hit play, we should spawn a whole row of little circles. As you can see, just following the target directly leads to a lot of crowding and crashing into each other. So hopefully the Boids behavior will take care of that. Okay, so the first script we're going to make is going to be called Boids separation. This is going to keep those circles from bumping into each other. And this is actually going to be a modified version of the flee behavior, because we're going to be running away from a point that is the aggregate of all of the different Boids that are next to us. It'll make sense as I go through. So desired separation is how much space we want in between every single unit. So I'm going to pick 15. This list of game objects is going to tell us where all of the fellow flock members are. Now we're going to override that get steering method. So we're going to make a new blank steering, and int count is going to keep track of how many different flock members there are. Now in the regular algorithm, we would divide our force by that count, so that way the aggregate becomes scaled and weighted, sort of. We're not going to do that in this one because it just doesn't work since we don't have the alignment Boid behavior. So now we're going to loop through every single Boid in the flock, and if it's close enough that we need to be repelled by it, we're going to add some sort of repulsion force away from that other Boid, and we're going to scale it by our distance from that Boid. So think about like bringing two magnets together, like they repel the closer you get. They repel more the closer you get them together. Each of those repulsion forces we're going to add to our total steering. Even though we're going to comment this out, I'm still going to include it so you can see how this would work. So normally we would want to reduce all these repulsion forces by the number of Boids that are repelling us, so that way we're not getting accelerated super fast. This works when you have the alignment behavior, so everybody's trying to align and go in a different, or like they're all trying to align each other and travel in parallel, basically. It doesn't work as well when all the Boids are clustering around a central target, so that's why I leave this part out. So now we're going to save it, and I'm going to leave a screenshot up for everybody to take a screenshot of. All the stuff's in the GitHub, yada yada yada, you know the drill. Alright, so the next Boid behavior is Boid cohesion. This is what's going to keep all the Boids clustered together and make them look like they're traveling as a flock. Alright, so this is going to inherit from agent behavior so that we can easily just return a steering object once again, and we're going to have neighbor dist, which which tells us how far away we want to be from all of the other Boids. So once again, we need a list of the Boids that we're going to keep track of, and then we're going to override that get steering method again. So this is pretty much the exact opposite of our Boid separation behavior. So this time we're going to look around all of our neighbors, find the aggregate center of all of them, if we can average the positions of all of them, and then we're going to aim for that spot. So we just sum up all the positions and then divide by however many different Boid positions we added together. And since our steering was created like in world coordinates, we're going to have to subtract our transform position from it to turn it into a vector that's relative to us. And I misspelled public, so make sure that's spelled right. And here's a screenshot for everybody to copy. Then you're going to save and go back into the editor. So we want to go into base behavior and add spots for us to attach the Boid cohesion and Boid separation script, just so we can access it easily. And we're going to start in the seek state, so that way I don't have to press space. And now we want to go to the seek script, and we want to attach the Boid separation and Boid cohesion behaviors, and we're going to weight them. I did 0.4 and 70, which those have quite a bit of disparity, but that's what worked for me, so I don't know. So now we'll see all these little doodads while they're following that squad leader. They're kind of avoiding each other, and they look a lot, they're moving a lot more organically than they were before. It looks a lot nicer. Obviously, this hasn't been tweaked, and these are really boring objects, so it doesn't look very good, but that's up to you guys to figure out how specifically to implement your stuff. And I didn't cover alignment. I will put some sources in the description that shows you how to make true and proper Boids. This is just kind of like a weird hack thing. But I hope you guys liked the video. I think for the next video, I'm gonna do formations. So you can either have Boids or formations. If you want to, might cover how to toggle between those two things. So yeah, all this is going to be up on GitHub. I'm going to put some sources in the description. Thanks for watching, and please click on my other videos if you like this one and subscribe. So cool, bye.